You know, and a lot of people don't understand. They say, oh, well, if it's out there and it's orbiting the sun, then I should be able to see it with my telescope. But that's the same as taking a drinking straw and going outside and holding that up to your eye. That's all you're going to see is that little diameter of your drinking straw. So no matter how big a telescope is, it's the same. And we know that they're covering this up. But the fact of the matter is, we have captured this large object, which is, it's about 3 to 5 times the size of Jupiter. The sun has captured it now. It is in approximately about 27 to 28 day orbit around the sun. As the sun rotates, it's literally rotating with the sun.
Hello friends. So there we have it. Looking through a telescope is like looking through a straw, according to Scott. Moreover, this is regardless of the size of the telescope. Well, once more, rest assured, Scott is wrong. Yet again. It seems that the expert is unaware of FOV, otherwise known as field of view, in both camera and telescopic fields, and other areas as well. The field of view definition is the open observable area a person can see through his or her eyes or via an optical device. In the case of optical devices and sensors, FOV describes the angle through which the device can pick up electromagnetic radiation, otherwise known as light. FOV allows for coverage of an area rather than a single focused point. And whilst I have been talking, the moon has cruised into view and just for us is in a parking orbit. This is a demonstration of what looking through a straw is like, and Scott is right inasmuch that a standard straw, when held to the eye, is just right to encapsulate the moon and indeed the sun perfectly. Hardly a surprise that both can be seen the same way if you think about solar eclipses. Before we move on, please do not look at the sun through a straw unless you are wearing solar filter eclipse glasses or have taken sufficient precautions to avoid damaging your eyes. Well, let's pop the straw in place and see how it looks. Interesting, yes, but well, it really does stop you seeing anything else. And here we are again, with the sun this time. And well, no, it's not any better, but no surprise. Here we are. This is the virtual view through my telescope using the 10mm eyepiece. The field of view is 0.7 degrees, whereas the sun's apparent diameter is around 0.5 degrees. So not a lot of wiggle room, but the telescope can be moved accurately to observe around the sun using the slow-mo controller and the right ascension motor drive I have fitted to the real one. Now, given that celestial objects within our solar system reflect the sun's light dependent on distance, size and composition, it is understood that anything closer to the sun, as claimed, should be brighter than both Mercury and Venus, especially if the fantasy sizes were true. Here is Jupiter to scale. It's big, but still dwarfed by the sun, of course. So let's have a look at the claim of a 3 times size Jupiter body. That's impressive, I'm sure you will agree. Though I believe planet Lichen, as photographed by Scott, is slightly bigger. Though he has since denied we will ever see Nibiru Planet X et al. From Earth. Best stop selling those books on Amazon then, Scott. Let us move on to the 5 times size Jupiter. Well, bugger me. We wouldn't notice this, bearing in mind what I said about reflecting the sun's light. please do not insult me with the powers that be are hiding it, using an unfeasible construction of a gargantuan proportion. There are so many holes in the sun seemingly to mean it would be more useful as a fantasy colander. Chemtrails don't do it either, as the sky has been seen to be entirely clear on many days. And now a simulation of what my camera can see. This is a direct connection straight to the focusing tube. This gives me a field of view of 1.68 by 1.13 degrees. Lots of viewing angle. But again, I can still move the telescope around to look and even rotate the camera to get a portrait view, or any angle in between. Let's pop Jupiter, again to scale, into view. Now the fantasy body, planet Lichen again. Followed by the 5 times Jupiter. Gosh, I do think a blind man could see these. And finally, this is the view if I fit the 2 times Barlow. As you can see, a much tighter shot, but still room left and right. The field of view is 0.848 by 0.565 degrees. This is half a direct fitted field of view. Again, I can move the telescope around, of course, to view the periphery of the sun. And here we go with the real Jupiter to scale again. Then, for the final time, planet Lichen, followed by the 5 times Jupiter. So there you have it. A telescope is not like looking through a straw. It is dependent on what eyepieces you fit, the use of Barlows to increase magnification of an eyepiece, and even focal reducers to reduce the magnification of an eyepiece. You use what is appropriate for a given situation. I start wide as a rule, as this aids with star finding. Then once centered, I change to a greater magnification to observe individual stars in a group. Well, I hope that clears up that misconception, though I know it's inconvenient to the narrative, Scott. Anyway, what happened to that telescope you had donated to you that cost thousands of dollars? You know the one. Available from all good stockists for less than $100, as it turned out.